Hi everybody, I just wanted to make a quick video here to help you guys figure out how to calculate series circuits. We're going to do a really simple problem here, but hopefully you guys can use this and go back to this video if you're having troubles with any of the work on Electude. So over here on the left you should see a very simple circuit. Remember that this guy right here is the symbol for a battery, so that's a battery. And then these little squiggly lines up here, this one, and this one, those are all resistors. Sorry, I'm not the greatest at drawing with paint, but I'm trying my best. Those are all resistors, right? So those three things are resistors. And the only thing we don't know in this circuit is the current. So the current is always going to be flowing. So this is the negative side of the terminal. This is the positive side of the terminal. It always flows from negative to positive, or this direction. So the current I is going this direction. Okay, so the current's going to be moving all the way this direction, all the way through the circuit, always in the same direction. And what's important to know about this circuit, series circuits, is that the current is going to be the same everywhere in the circuit. If you think about it, there's little electrons, little balls of electrons moving down this wire. They're moving really, really fast, but when they hit these resistors, they have to slow down. Just think about like cars and traffic, right? They got to slow down here. But if they slow down here, then they're going to have to slow down back here, right? The traffic's going to get backed up. So the current throughout the entire circuit is the same, because you can imagine this is like traffic where there's all the cars are bumper to bumper the whole way in traffic, and so they have to, one electron can't pass another electron, right? They're all bumped up against each other. So the slowest part of the circuit, they're all going to have to be moving at that speed throughout the entire circuit so that they don't run over each other, if that makes sense. So the current's the same everywhere in the circuit. And we know the voltage is 12 volts. Remember, that's the potential, how badly the electrons want to flow. And then we know the value of our resistors. So the only thing we don't know in the circuit is the current, and that's what we're going to try to solve for. So we have to remember our Ohm's law equation, which is very simple. V equals IR, or voltage equals current times resistance. Remember, this is the total resistance. I'm going to write that down here. This is R total. The total resistance in the circuit. Okay. Remember, we can manipulate this equation really easily. It could be V equals IR. We could write I equals V divided by R. Or we could rewrite it as R equals V divided by I. So if that's confusing, don't worry about it. Hopefully that's something you guys will understand more and more as you take more algebra, more math classes. But these three equations are all the same thing, just rearranged, solving for different things. So if you're trying to solve for the current, like we are in this problem, we'd want to use this equation. But if you wanted to solve for the total resistance, you might want to use this equation on the right. Or if you were trying to solve for the voltage, you'd use this equation on the left. So we're going to use this middle equation, because we don't know I. We're trying to solve for I, so we're going to say I is equal. We know that our voltage is equal to 12 volts. And then the tricky part is, what is R total? And it's really not that tricky in this situation. R total is adding up all of the resistors. So I'm going to show that a separate equation over here. So R total, I'm sorry, I'm so slow with paint. R total is going to be equal to R1 plus R2 plus R3. So that's going to be our total resistance. In this case, that's really simple. I made the numbers really easy. That's 1 ohm plus 2 ohms plus 3 ohms for a total of 6. Oopsies. Work on my drawing skills. A total of 6 ohms. That's the symbol for ohms, if you don't remember. So the total resistance then is 6. We just added all of the resistors up. So we're going to put 6 down here. And that means current is equal to 12 volts divided by 6 ohms for a simple current of 2 amps. there it is. That's it. So it doesn't matter if we're solving for a current or if we're solving for resistance or if we're solving for voltage, the process is all pretty much the same. Okay. Remember, the current is going to be the same everywhere in the circuit. The voltage will be different at different places in the circuit, and we can talk about that in class a little bit. But for the most part, this is the main equation you're going to be using, and you're going to be solving for any unknowns in the circuit. I know this might be a little tricky, kind of hard to visualize, but please stick with it. Khan Academy is also another great resource if you guys want to use Khan Academy, but it is going to take a little while to wrap your head around these ideas. So this is calculating series, and I'll make another short video to calculate circuits that are in parallel. All right, take it easy, guys.